Okay, another day working with rotations around the x-axis. We'll have a bunch of flat disks, just like Earth. Right? That's why we call it the disk method, because we'll be spinning these things around. Okay, I know the Earth isn't really flat like a pancake; it's actually donut shaped, but you get the general idea. 1 over square root of x. Of course, Desmos can graph that curve for me. Notice today we're not starting at 0. We're going to actually start at different numbers. This one we happen to start at 1, and we'll stop at e. There's my attempt at making it look like a 3-dimensional object after rotation. Of course, the radius for any cross-section would be 1 over square root of x. And so the area of a circle, of course, is pi r squared. In our case, it becomes pi times radius squared. Hey, 1 times 1 is 1. And then square root of x times square root of x is just plain old x. So that's kind of nice. And of course, it becomes volume if we think about the thickness of that slice. Right? So it's a circular slice, put in a little bit of thickness, and we got volume. So we need to go from 1 to e, and we need to integrate 1 over x dx. Again, since pi is just a coefficient, I put that out in front of the integral symbol to save myself a little bit of time consumption. Hey, what happens if we integrate 1 over x? Well, you get natural log of x. Plug in the values. So I got to figure out the natural log of e. Got to figure out the natural log of 1. Yeah, touch a calculator. Give me a break. Natural log of e is just 1. Right? E to the first power gets me e. Natural log of 1 is just 0. Right? E to the 0 power gets me 1. Hey, I just got pi times 1. I just got pi. Right? He was like, oh my goodness, that was so much less step-by-step work than those crazy examples the previous lesson. Yeah, previous lesson, right, we had some kind of friendly looking equations, but then when we realized we had to square the radius, they get kind of ugly. Here's one where maybe at first glance, it's like, oh no, 1 over square root of x, but when we squared it, it came out quite nice. So on your assignment today, again, at first glance, you're thinking, oh no, square root of cosine x. How am I going to integrate that? Remember, area is pi r squared, so the radius is going to get squared. So at first glance, if you're thinking, oh no, this is going to be a nightmare, it's actually going to involve very little step-by-step work. Again, that is my attempt to make it look like a 3-dimensional rotation. And so we want to go from pi over 6 to pi over 2, which means you're going to have to plug in some values. If you've got to memorize, great. If you need to refer to the unit circle real quickly, that'd be awesome also. So in that 3-dimensional shape, if you think about like dots, candies, right? They're kind of like, well, I guess they call them gumdrops. Yeah, so they're like gumdrops. And if you thought about like rotating windows on their side, that's kind of what this 3-dimensional shape looks like. So it's not really a cone. It's well, I don't know how you describe this shape, but gumdrop, right? Gumdrop shape. But that's going to be the assignment on the worksheet today. Surprise, surprise, the mystery word, as always, is worksheet. And instead of the Earth looking like a pancake or the Earth looking like a donut, thank goodness our Earth actually has some beauty about it, and it's a sphere.